think you can start the recording.
Yep, it's done.
All right. So everyone can see the screen? Everyone can see the screen?
Yes.
Yes,
Nice. Nice. So, a couple of things quickly I wanted to talk about from the logistics point of view. Thank you for joining and learning. This is really good. To be very honest, our program that we are doing right now is being watched by a number of people in Canada, those who don't join in the sessions, but still there's a lot of people are starting to talk about what we as a Wavelabs brand and as a Brampton city and as a community, local community here are able to do is really appreciated, which is a good thing from my view, right? The other thing that I was wanting to talk about is in order to continue this combination of Brampton, Wavelabs, and Testoper journey, right? We also plan to do, I don't know if you guys have actually seen this or not. Let me see if I can pull this up. This is very important in terms of helping people to learn, right? Let me see, where is it? Yeah. I don't know how many of you have seen this one. So we got a overwhelming response, right? With respect to the impressions and the conference that we are planning to actually do, right? With a similar combination of, the government, city of Brampton, right? From government point of view and from the industry point of view, Wavelabs leading, and from the community point of view, the local community, Testoper leading, we are continuing this journey. Overwhelming response. There's a lot of good things are happening. So one kind request that I want to ask you all is, if you have not liked and reshared this post, I would kindly request do a help of doing it. That will be appreciated. I'm just going to share this in the chat. Right. Okay. And the other thing is, of course, the quick logistics. Just typing it in the chat here as well. Let me see, where was it? Yeah, so typical stuff, right? If you wanted to support the first 3 links, if you want to register for the future 4 or 5 sessions, you can go and register it. We sincerely appreciate and request you registering it. And in case you're not registering, a little bit lazy, you can copy this and you can directly join. You can put it in your calendar and directly join, right? I would sincerely appreciate it. Okay, so with that, let's see if we can get started today. So we know the purpose, right? We all wanted to develop our experience, expertise and ecosystem experience, right? On 5G technology. That's why we are here. Let me go back to this most important thing, right? So the first 30 minutes is always about learning the fundamentals, because what's important is understanding an end-to-end picture is very, very important. And then it will allow you to see the big picture and start getting into the details and do justice for your job, right? So that's the thought process. We already went through wireline networks, the fundamentals, wireline networks, the fundamentals. We went through standards and open source last week. It took considerably a lot of time. Now we are going to start learning about adjacent technologies, how different technologies are actually helping the 5G, right? And understanding the basics of those technologies. The advanced thing is obviously is the process of continuous learning. You can continue to learn them, and maybe there are many sessions that we have done in AI, cloud computing. It's all available in the YouTube. You can look at it if you wanted to get into the details, but here the idea is to give you enough so you understand the basics. So once you're strong in basics, rest of the things fall in place automatically, right? And then finally, we will look at the spectrum, right? I'm going to skip the slides because we have already gone through this. If you think about it, we have learned a lot together in the last 7-8 sessions. It's really, from that point of view, quite amazing, right? So last session, we talked about the standards, how important the standards and open sources are for the deployment of any networks, right? Today 5G and in future 6G. How important it is, these networks can support different use cases from metaverse to, fixed wireless access to private networks to whatnot, right? How it's very important to have a interoperable network product that can allow you to deploy all these different use cases, leveraging different technologies. So standard becomes very, very important. And open source kind of helps you to accelerate the development and go to market, right? So if you think about it in the past, when the open source was not there, any company to build the products and go to market takes months, in some cases years. Now different companies are coming together and creating a group of people, 50, 100 people developing something. Think about if you have to do it as your own company, it would probably requires lots of investment to get there, right? So it's a joint investment and joint success, open source that really helps. So that's what we kind of looked at in our previous session, how different standard bodies and open source community, how important, what are the different standard bodies and open source community, and some we took as an example. And we also talked about how important these two have, is going to help us to become successful. And also, it's more equally important that both of them start to work together, right? In the past, it was not. Now I see a lot of activities collaboratively happening between the open source and the standard bodies, which will really help us to, accelerate the adoption of the new technologies. Otherwise, it's impossible, right? And that's why in olden days, you learn something, you can live with it for 5 years, 10 years. You can continue to do the job. But now you got to learn every day. Every day something is new. At least if I look at it as a person, right, I feel like there are so many things coming every day, and it's so difficult to keep up, right? So that's something that I wanted to share it with you. From the open source point of view, as well as from the standard point of view, it's very important you understand the what and how these two things are contributes, and understand the importance of how both the things have to come together and work together to accelerate the adoption of different technologies, deliver products, and help with the customers. It's very, very important, right? So that we went through some of them, and we looked at different standard bodies, and also we looked at different groups and communities and organizations that coordinate between the standard bodies, customers, open sources, and try to bring things together to, again, help the vendors out there, operators out there, and all the ecosystem players that are out there. There's a number of organizations are like that, right? Some examples, we looked at TIP, and we looked at connected industries, and there is a connected automation, automobile industries. There are so many different industries that does this job to bring the open source and the standards from different places together to solve particular domain or particular industry challenges, right? So that's also something that you need to understand. So you have standard body, open source, and there is some in between which brings everything together and addresses the focused use cases. Okay, those are key things for you to understand from the standard bodies point of view, which we went through quite a bit details in the previous session. I just wanted to sum it up so you understand. It's not about learning it, you understand how is it actually going to help you and your company, and how you can leverage whatever that you have learned in practical aspect is key. Okay, moving forward, now we jump into this adjacent technologies. I try to draw some pictures by myself whenever I get time. These are not perfect pictures copied from here and there, right? So there may be some mistakes in the picture with the disclaimer. My idea here is, Yokesh and team are starting to talk about Orchestrator and NMS. So I wanted to kind of help you understand the fundamentals of that leads to what they are going to talk about, right? So that I may not be able to cover everything, but I want to get started now. And then in subsequent next 4 or 5 sessions, I'll try to complete many other adjacent technologies, including AI and other adjacent technologies. And then we will, end with Spectrum, right? So that's the thought process. Now let's get started. So we all know what is cloud, right? I mean, cloud is not real cloud, right? It's still a bunch of hardware. Only thing is, in a office, before we used to have a bunch of hardware where all our stuff used to run, right? Applications or whatnot. Now instead of putting it in our office, we are putting it in some other location, and many offices are accessing it, right? So because it's there in some other location, it became cloud, right? It's not in your location, it's in some other location, um, hosted by someone else that you are leveraging, right? Because it's not owned by you, it's somewhere else, it became cloud, right? That's how the name cloud is. But end of the day, it's nothing but whatever you used to have in your office, it's somewhere else, and it is provided by someone else, right? That's what it is. It's very important to understand. So when you talk about cloud, if you think about it, how actually it all started, is it started in mostly, the web world, right? Web 1.0, 1.2, web, sorry, 1.0, 2.0, and 3.0. There was an evolution of web technologies. So, web 1.0 is all about, you can know whatever was there available in the web, right? Web 2.0 is all about you can contribute to the web, right? That's where the Facebook and all this Twitter and everything came in, right? Before it was read only, then it became read and write. That's Web 2.0. Now Web 3.0 is you can be inside the web and do stuff, metaverse, right? Digitization and number of things, right? So that's Web 3.0, and metaverse is one of the use case of Web 3.0, right? And it's all about decentralizing is de-aggregating it rather than one person owning it, like Twitter or anyone. How a lot of different companies can own the ecosystem rather than one person owning it, is all about Web 3.0, right? Blockchain, if you have heard of it, it is a decentralized finance, right? It allows you to do that. And nowadays, the blockchain is allowing you to do decentralized wireless and decentralized XXX, right? Many different types of use cases that you can create a decentralized using blockchain. So that's what it is. When you look up from the cloud point of view, it all started from when Web 1.0 and the enterprises, right? Rather than they owning everything, they thought if someone else can own and manage and give it to us, it will be a valuable for us, right? So that's how it all started. And mostly enterprise applications were deployed on the cloud. And some university applications, this, that were deployed. And at that point of time, it started as infrastructure, right? Providing infrastructure to multiple companies from a common place. That is how it started. Then it started platform. Then it started as a service. Nowadays, it's got everything is deployed in the cloud and provided as a service. I've actually given a link in the next slide to see, what are all the different types of services as a service model nowadays has come. When it comes to 5G, we are talking about network as a service, right? But then at that time, this is how it all kind of started. And obviously, it had brought many benefits, right? You can virtualize it, you can manage it, you can allow multiple enterprises to access the same data center farm, which is so-called cloud, but still isolate their data as a multi-tenant, not mix up the data with other enterprises and secure them. Those kind of advantages came into the picture. Then slowly, instead of allocating the fixed resources, how can I allocate resources on demand? Then elasticity feature came in, right? Increasing and decreasing the resources depending upon the need. Then it became very evident that you can't do everything manually. So automation becomes very important to really automate everything in a way that you can manage this cloud infrastructure. That brought in innovation, helped small enterprise to start the company. Before even you want to start a company, you have to be a millionaire. It was otherwise you can start a tech company, right? Otherwise you can start a non-tech company. That's a different story. But then now just a bunch of people come together, even one person can come and reserve a PM and put his website, and he can start his own company. That allows openness, allows innovation, and a lot of different advantages came in, right? These are all some of the advantages. Over the period of time it evolved, and mostly it started with x86 servers, but then now if you look at it, every different possible server architectures, from FPGAs to the GPUs to you name it, right, is available in this data center nowadays. So that's what the cloud is all about. That is how the cloud got came into the picture, into our lives, right? At that time, they gave multiple different types of names for the cloud. It was quite obvious, right? Nowadays, probably some may be applicable, some may not be applicable, but they got to give some names. So they kind of giving names like public cloud, meaning some third party guy having a data center and providing the services. All your data is stored in he's a public operator, right? A public cloud operator. If everything is stored in his data center, then it's called as a public cloud. And if you kind of have a space where you have half your own servers, half you're using from third-party servers, and you're placing your data some in your place locally or in that particular location owned by you or someone, it becomes a hybrid, right? Some kind of, you don't want to share everything to the public operator. You want to keep something to your own, then that becomes hybrid. Then private, you don't want to give anything to them. You want to keep it. But the difference between the private cloud and the way that we used to do before is there was no virtualization, there was no multi-tenant, there was no OpenStack, there was no cloud stack. There was nothing of that sort, right? You basically put an OS and then you put your application, you run it. But then when you put this virtualization and the cloud stack, OpenStack, everything, even in your premise, right, then that becomes a public cloud. Because why the cloud, right? It's kind of, it virtualizes, right? Virtualization and cloud has a relatively close meaning, right? So if you have all those virtualization technologies, whether it is a VM container ship and you have installed that and you're managing all your hardware in your own premise, then it becomes a private cloud. And community cloud is a little bit different in the sense that, okay, different groups come together and say, hey, let's build a data center only for our own purpose, and we will share only among ourselves for this particular need and use case. Then it becomes a community cloud. It's just a concept where you're actually putting your infrastructure is basically determines the name of the different clouds, right? Now, cloud, I talked about this infrastructure as a service, right? So at that starting point, when it started, what happened was they just provided only hardware. Then they said, okay, just providing the hardware is not going to be beneficial for me. Let me put some hypervisors and everything so that I can manage and provide virtual stuff, right? So it all became as an infrastructure as a service. Then once the infrastructure as a service was provided, then they thought maybe we should further ease the enterprise effort using these cloud, right? Then what happened was the cloud providers started putting operating system and all the tools, frameworks, and everything into their cloud. And they said, hey, all these things is available. You don't need to install. You just have to take it from my marketplace and put it in and take it forward, right? So they started providing platform as a service. Then there were so many innovation came in, and the software as a service also was provided, right? SAP, Salesforce, and all these things are the software as a service. Now, this is how it all started before. And I kind of Googled and I was just wanting to share this link. So if you go to this particular link here, right, it says big as a service list of as a service offering. So if you go and look at it nowadays, everything is as a service. Artificial intelligence, models and everything you provide, and you provide that as a service. Backend as a service, database as a service, container as a service, everything, right? Desktop as a service, you can provide even a desktop. So there's so many innovation in this. Network as a service, IoT as a service, knowledge as a service, right? Network as a service, which is more relevant for it. So the point I wanted to basically tell you is that in one way, it eases it and enables the innovation for the people to focus on use cases and try to solve the problem rather than getting too technical into this, right? And this is the pro, right? But at the same time, the con is if something happens inside, you really don't know, right? What's actually happening inside. So you as an individual, depending upon the knowledge that you have or the knowledge that you would like to evolve as a continuous learning, the more you know, the better you are in this whole ecosystem. But again, you have to abstract yourself. And if you're just going to focus on just use case and you want to build some small application, then you can actually use. Nowadays, there is something called as a function as a service. You wouldn't believe. All you have to do is a main program you have to write. You don't even have to write function. All functions are available as a service for you. right? You put a main program, you put your flow chart, this is what it is, find out which functions, and you just put it, and that function, whatever, and then you can build it. So it makes you dumb in one way, but in other way, it allows you to innovate and focus on what you wanted to do, right? Rather than thinking what is not required for you to do. So that's the cloud, okay? And then the second one is the SDN. And I have better diagrams I try to draw this one. I kind of copied it. I try to draw some diagrams to make it a little bit simple. But what is the SDN is, it's the same way, right? Who initiated this, like enterprise IT, and why did they actually do this? It kind of evolved in the campus, right, and matured in the data centers. It actually started in the campus and then matured into the data centers. And what does it actually mean is you used to use expensive L1, L2, L3 equipments, right? How can we, and it's also complex, right? With all these protocols that helps you to transport the data on the transport networks. It's very complex as well, expensive and complex. Then they wanted to see how I can softwareize it. And that's when this SDN kind of came into the picture, right? And what they wanted to really do is take, just a good example is take a router and split the two parts within the router, right? One part is the one that controls, right? The protocols and everything, controls part of it. And another one is the actual switching the traffic and moving part of it, right? So you have the control part of it and you have the traffic moving part of it. How can I separate these two things? And how can I centralize the control? And how can I centralize the control side of the logic? And then how can I route the traffic across multiple low, in other words, less expensive devices, right? It's called as a bare metal devices. Rather than buying a big router and big switches, how can I actually do this in a cost-effective way by splitting the control portion of the router and then making that control portion to route the actual traffic over a cheaper hardware, right? That is what was the thought process. And then with that thought process, this whole SDN evolved, right? And some of the open sources like Open Daylight is one of the open source that provides you that control part of it. The control part of it, they call it as an SDN controller, right? And then the actual traffic routers that you put it on the bare metal and you just switch the traffic, that's your user plane of that SDN. And then the control plane SDN controller controls all these small boxes through some protocols, right? I've given an example. Some controls through OpenFlow, majority, some controls through XMPP, and some also has a proprietary protocols and things like that. But the advantage here, again, if you think about it, right, the natural flow of understanding the standards and open source and coming to this adjacent technologies is because of that, right? So the Open Daylight and OpenFlow, all these things are the open source, number one, right? And then number two, the standard bodies define these protocols. That's number two, right? So open source and standard bodies coming together so that how we can reduce the total cost of ownership of the equipments, right? End of the day, that's what it is, right? The cloud is also all about that. SDN is also all about that. NFV is also all about that, which we will learn in our next session. Okay, so that's one thing, right? And the second thing is it brings in a lot of flexibility, right? You can kind of put your SDN controller in the VMs or in the containers, and you can do all those beautiful things that cloud allows you to do, right? Multi-tenant innovation and things like that, right? So end of the day, so SDN is all about, simple way to remember is instead of buying a router, take a router, separate the control plane, call it as a SDN controller that controls low expensive hardware that's going to help you to switch the traffic. So that's what the SDN is all about, right? So now if you think about, just as a summary for today, cloud plus SDN, if you think about it, all the applications of the cloud was running in the, let's say for our discussion, public cloud. This is a very bad diagram. I drew it quickly to explain, right? It's just for the explanation purpose. Okay, so you have this cloud and you have all the applications that's running on the cloud. Then you have the transport network, right? You have an access network, then you have a transport network, which is something that we learned in our wireline and wireless network introduction, right? Now, what happens is you have a controller, right? SDN controller that controls all the small hardwares like this. and it kind of tells when someone is calling from here to here, it tells, okay, this SDN controller gets the information through the applications or whatever, right? There's a number of ways to get it. We will look at it in the next session. But once it has the information that the traffic has to be routed from A to B, then what it does is it kind of connects multiple small, low expensive hardwares to move the traffic from the origination to the destination. Right? So that's what this SDN controller does to transport the traffic in the transport network between two starting and ending point through any type of different types of or any / different types of access networks. So that's the kind of basic understanding I wanted you to have, right? So where did the cloud start? Why did this SDN start? And it's all about bringing open source standard bodies together, reducing the cost so that, reducing the cost, improving the innovation so that the companies can afford and innovate. So they are able to do good business and economic growth, right? So that's pretty much it is. And another key reason, if you think about from a layman point of view, is that we used to pay before to use a phone 15 years ago, monthly 4,000, 5,000 rupees. That time, 4,000, 5,000 rupees is like today's 4 lakhs rupees, right? maybe more. But at that time, you pay thousands of dollars per month to keep the phone. Nowadays, and just to do voice call. And nowadays, we wanted to pay only like 500 rupees and we want voice, data, high throughput, want to watch video and everything. How is it in the earth possible to provide all those things from the money that it was earned from one person so much to now down to 500 rupees and things like that in India and similarly around the globe in different currencies? You just can't do it, right? And the only way to do it is bringing innovation and softwareizing it and reducing the cost, right? That's also another practical reason why all these different technologies came into the picture. I will pause here just to give you the perspective, right? What you understood is cloud and SDN. What I wanted to do is build upon on that NFV and then see how all these different things comes together and things like that, right? So that's what I wanted to take you guys through. So once we have this basic fundamental things about cloud, SDN and NFV, then it becomes easy to talk about additional other technologies that's actually going to help in the blueprint of evolving this 5G network, more effective network deployments for today and tomorrow, the 6G, right? So that's pretty much I wanted to share for today. With that, I will pause my session and hand over it to Yokesh and team to continue on Magma portion of it. And today, what they're going to talk about is the NMS and orchestration, which they talked last session, but at a they had less time. Now they have like 25 minutes. So they'll refresh that and they'll talk about it. Now, if you look at this NMS and orchestration, right, that's the controller part of it at a high level, right? That's going to really help to control make the Magma Converged Core Network in A gateway sync to the tune of that, right? Let's put it like that. So that's what Yokesh and team are going to take over from here. With that, Yokesh, over to you.
Sure. Thanks, Kader. Thank you for setting up the ground. So yeah, as Kader mentioned, today we are going to just do a recap of the previous session, and then Lavanya is going to show the demo video for NMS and orchestration. Lavanya?
Yes, I'll start this. So, good morning, good evening.
Lavanya, your voice, I'm not sure. It's only me. Can you come closer to the mic?
Yes, sir. Is it better now?
Yeah.
Yeah,
Can you come a bit more closer?
Bit better.
1 second. Hello. Is it better now?
Yes, little better. Go ahead.
Yeah, it's better.
Okay. Okay, so I believe my screen is visible to everyone. And yeah.
Lavanya, sorry to say this. Maybe you have some fan or something running close to your mic.
I'll change my mic just one second. Yes, Kaja, is it better now?
Yes, it's better. Please go ahead.
Okay. So yeah, or one second.
Can you put it in presentation mode?
Yes, so I believe my screen is visible to everyone. And yeah, I'll start the session. So we had in the last session we discussed about orchestrator and NMS and what are the different features of it and how do we enable different configurations, how do we enable it and how do we make it and how do we integrate it with Magma. So just for the context, as Kader already mentioned about cloud, so in the previous sessions when we started this discussion, this decoding 5G sessions, we have started with CLI based interfaces. So we introduced OAI simulator, we introduced Magma, we introduced different call flows, and we also demonstrated all of them. But most of them were demonstrated in a CLI based environment, and that is how developers use it. But when we deploy it in a commercial way, we need some GUI based environment so that we can set up the configurations. Even non-developer people can configure it and operate it. So that is where this orchestrator and NMS comes in the picture. So yeah. This orchestrator and NMS are hosted in cloud-based environment, and we can also deploy it on our local laptop setup just for testing purposes. So in the demonstration video which I'll be showing, I have hosted it on my laptop setup only using Docker containers. But yeah, in a more traditional way, it is hosted over the cloud environment, AWS environment, and Wavelabs also provide one such setup for users to test it. So you can contact us over Slack if you want. So moving forward, so this was the agenda which we discussed in the last session, and we started with orchestrator and what were the orchestrator and NMS quick installation guides. Then move forward with the Swagger API. Then how do we check the health of the connections of orchestrator and AGW? And all these things have been covered. So I'll quickly browse through the slide so that you get a quick recap of it and you get the context of the demonstration video. Now, so next slide. Orchestrator. So yeah, we already saw this basic architecture of orchestrator, that how this is how it is connected to other components and what are the two interfaces, one northbound interfaces there, one southbound interfaces there, and what are the different purposes of the interfaces. Like the northbound interface is used to expose the configurations and matrices of the network devices, and the southbound applies the configurations on the AGW and report the device status. So next slide, I'll move. And this was the quick installation guide of orchestrator, where we saw that how we can deploy it. There are different flavors of deployment: bare metal, Kubernetes, AWS, cloud, and all that. And for local deployment, we can follow the second guide, quick start installation guide. We can follow. Next slide, I'll move. And this is Swagger API. So I'll be demonstrating it in the video also. So this is how we can configure the AGW, and we can using the REST API interfaces. We can post. We can use different methods like get, post, delete, and all that, and we can send different configurations and command, and after which the AGW will comply to that. And yeah, this is how we check the health of that whole infrastructure, and that how orchestrator is connected and whether the connection is good or not. So this part also I'll be covering in the video, how we run it and If the health is not good, then this command itself will give us the different ways to resolve it and troubleshoot it. So I'll move to next slide. So yeah, the basic NMS dashboard view, this is how it looks when we run it for the first time. And this slide is particularly important, as in the video I'll be demonstrating how to enable the network to a particular organization. Otherwise, this is how your NMS dashboard would look like, and it would be difficult for you to add a network. So this is a new change, and it is there in the latest master, so I'll be discussing it. So yeah, this organization tab is a new particular change that is there in the latest master, and here we have to enable the networks for a particular organization. Then only that organization's NMS will be able to access that particular network. So moving on. So yeah, once that network is enabled in that particular organization, this is how the NMS dashboard looks like. And there are different buttons in the left hand side, we can see, and using which we can configure or we can see the different parameters and matrices of the network and of our equipment as well. And we can also configure, delete, or edit the subscribers different parameters. So that also I'll be discussing in the next slides, and I'll also demonstrate it in the video. Adding subscriber. So this is the view of the tab which is used to add the subscribers. So this I'll also demonstrate it in the video, but for a quick view, there are two ways to add it. We can either add it using the CSV file, or we can add it one by one using add new row method. So yeah, this is how we add a new subscriber, and I'll demonstrate it in the video as well. And this is how your CSV file looks like when you are trying to add multiple subscribers. This is the format you must follow. You must start with the first cell in the first row, and then you have to put the different parameters accordingly as it was appearing in the previous slide. That is, first you have to put it the IMSI, then the subscriber name, auth key, auth OPC, and service, and all the different parameters. And if you want to leave any, if you don't want to include any particular parameter which is not compulsory parameter, then you must like keep that particular cell blank. So like this in the F this row, I've kept it blank because I didn't want to add that field. So next slide. So once that subscribers are added, we can also verify whether the subscriber has been added or not. So we can run this particular command, subscriber CLI pi list, and if the subscriber are added, it will be part of the output. If not, then it will not be there in the output. And we can also check the different parameters of that particular subscriber using subscriber CLI get command. So yeah, policy configurations. So this is the tab where we configure the policies, and as discussed in the last session, policies are the way through which we can control the behavior of the particular subscriber. That is technical parameters, basically, that what is the speed that it is allowed, and what are the different sites which it is allowed to access, and what sites it can't access. So that kind of parameters and many more things. Basically, the quality of services are controlled by the policy. So yeah, this is how we add it in the NMS. Next slide. Once that policies are added, we can verify the policies using this particular command, policy db CLI pi dump data. And in this policy db CLI dump data, the output will, the first line of the output will show you which particular subscriber has which policy enabled. Right now, none of the subscriber that I had added was having any policies, but if any policy would be there, after colon it would appear. And later on, as I'll demonstrate in the video, we can also see that all the particular policies that are there in our database policy DB. So moving on. And this is the final field that I'd be covering in this presentation, that is GRAFANA. So GRAFANA is used to capture different matrices of the AGW including the subscriber matrices, that is the data being they are using and the throughput they are getting. And we can also access other parameters of AGW, that is machine memory and the number of core that is being utilized. All that can be viewed in a graphical and a presentable format in the Grafana dashboard in the NMS. Next slide, I'll move. So yeah, now I'll start with the demonstration video. So that in the demonstration video, my setup has this particular topology. I have one AGW that is connected with the orchestrator and NMS. This orchestrator and NMS are running in my local laptop over Docker containers, and AGW is running in a VM that is too in my local laptop itself. So I'll start with the video. So yeah, starting we can see that this is the this is the Swagger API of orchestrator. This is how we can give complicated commands to AGW. We can use the REST API methods to send it to the AGW side, and it will comply. So yeah, now we can see that how to verify that connection that is there. That is the health of connection between orchestrator and AGW. So when I run this command, we can see that it is successful. And if it was not successful, then it would also tell us what are the different ways to debug that issue. So yeah, this was what I was talking about, that organizations tab. So yeah, we can see that I have this particular organization Magma test, which I'll be using in the subsequent part of the video, and how I can enable a particular network to it, that is test network. So this is how we click on the advanced settings, and then we can click on that accessible networks and click on that particular network and then save it. So it will be accessible to that particular organization. And in the URL also we can see that the name of my network is there as a part of the URL, that is magmatest.localhost, and that was the main organization, that is the host.localhost. So we can see it here, host.localhost, and now we are moving to that particular organization, that is Magma Test. So yeah, this first tab is the equipment tab. So this is where we can check the status of our equipment from the NMS side, that is the health and all that thing that can be verified from here as well, the way we were verifying it from the CLI. And right now we can see the health is good and all the logs are enabled. If there's any problem, we can debug it in that tab. So this is the network tab. This is where we check the different network parameters, like for the EPC parameters, we can check what is the MCC, MNC, TAC values that are configured, and if we want to change, we can change it as well using the edit button. And for the RAN side, we can check what are the bandwidth, RAN configuration, and all that different parameters are there. We can check it here as well. So all the network related parameters are available in this particular tab. In the third button for the left top corner, and yeah, we can configure it as well here. So yeah, this fourth button is of subscriber. So this is the view of subscriber tab, and right now I have all this mini subscriber added in my NMS. So I'll delete it and show you how we can delete it and then add it again. So deleting subscriber is pretty easy. We select all the subscriber to be deleted and then delete it. So it will be deleted if we refresh it. So yeah, now there is no subscriber there. So I'll add a new. So this is for adding particular subscriber one by one. We click on add new row, and then we enter the different fields and parameter, and then we click on the tick mark button, that is correct button, and after that only we have to click on save and add subscriber. But I'll also demonstrate how to add many subscriber one at a time, all together. So we will use that CSV upload method, and yeah, upload CSV, and then I'll upload that CSV file. And yeah, when I click on save, it will be saved here. And now coming to that CLI part, we can verify whether subscribers are added or not. So yeah, the list we can see all the subscriber went like are part of the output, so they are added. So now we are coming to policy. So there are two policies that are there already, and I'll add a new policy just to demonstrate it. So before adding a policy, we have to create a profile for that policy, which will contain class ID and maximum bandwidth for downlink and uplink. Class ID is comparable to QFI value, and maximum bandwidth can be that amber value which you need to know. Now we have to add that policy and select that QoS profile which we created just right now, that is profiling. And in flows we can accept or deny that source IP addresses and add all the other parameters here. So if a packet comes from this particular IP or this particular network, then it will trigger that particular QoS profile, that is whatever the uplink, downlink, bandwidth, whichever I set, it will take over, and that would be the speed. So as we know, many of that operators use it for advertisement purposes, like giving particular website more bandwidth than others. So yeah, that kind of thing we can configure it in the policies. Now we are verifying the policy whether they are added or not. So this command I'll run, policy db CLI by dump data. But yeah, one thing to note here, I did not apply or enforce this policy in any subscriber. So all the above field would be empty, which we can see. Yeah, all the subscriber don't have any enforced policy, so that is why these fields are empty. After colon there is nothing. But if I enforce any particular policy to a subscriber, it will be visible in the output of this command. So base names also I did not added, but yeah, policy rules I added. So we can see right now the old policies are only there, so it takes some time to reflect it. So I'll run the command again, and now we can see this policy A got added in the policy DB rules. So yeah, it has been updated in the policy DB as well from the NMS side, and we can use it and we can add it to any particular subscriber. Now moving forward, I'll be demonstrating the last section, that is Grafana dashboard. So yeah, in this side we can select the particular time or time interval which we want to check, and we can also select that particular subscriber. We can scroll down to select any subscriber. This is not searchable as of now, but yeah, that is something that we can work on in future. So, and in the gateway we can select the different, we can check the different parameters like latency, what was the memory usage, and all that different fields we can check. So yeah, this was Grafana dashboard. And yeah, this takes us to the end of the presentation. So I'll open the slide once more. So yeah, I'll just summarize the demonstration video. So we started with talking about Orchestrator and Grafana, and in the beginning, Kader already introduced about cloud services and and that is where this Orchestrator comes into picture. It is hosted in the cloud and it can control different network. It can control different AGWs as well. So we can add different network, we can add different organizations, and all the organizations can have their particular network. So this private 5G theme is totally based upon, like Orchestrator is totally based upon the private 5G theme, and we can use it to enable such services or create such setups. So after that, we moved forward and we had a look on how do we check the different parameters in the AGW side, how we can verify whether the services are up or not, and how do we add different services, how do we add different subscriber configurations, how do we add different policies to the network, and then how we can verify it from the AGW CLI part. And in the end, we verified that we saw that how we can check that graphical view of the different parameters that we have enabled in the in the NMS dashboard, and what are the different parameters of the subscriber, that all we can see in a presentable form in the Grafana dashboard. So that was my presentation. Thank you.
Okay, good work. Nicely presented. Thanks a lot, Lavanya.
Thank you, Kader.
Any questions from anyone? Nice. Okay, so that brings us towards end of the session. We have 4 minutes to go. You know what? I would be doing justice to give you guys back that 4 minutes. Now 3 minutes. Have a wonderful Saturday evening, and I'll talk to you all very soon in 2 weeks. Take care. Bye-bye.
Thank you. Bye.
Thank you all.